Welcome everybody to Streaming Data Pipelines for Real-Time Analytics. My name is Sai Madali. I'm a Senior Product Manager with the Amazon Kinesis service here at AWS. In the webinar today, we're going to touch upon three aspects. We're going to look at what is data streaming, why are customers generally interested in data streaming, and then we're going to look at how Amazon Kinesis helps customers leverage the power of data streaming. Finally, we're going to look at some of the use cases that you can get started with, especially if you're new to data streaming, you're looking to get started. We're going to talk about what are some of those low-hanging use cases that you can get started. All right, so let's talk about what is data streaming. The data streaming typically is a means to the end, and the end is typically really driven by the need for business to take really timely decisions. Survey after surveys, what we hear from customers is they see a significant increase in things like customer retention, loyalty, increase in revenue usage, as well as decrease in costs when they have access or when they're able to look at data and be able to make quicker decisions. And we were looking at quicker decisions. We're talking about being able to react in few minutes versus days and hours in the past. Also, we've heard from customers that not being able to access or being able to make timely decisions kind of inhibits them from maximizing their business opportunities. When the business was okay to look at historical data to make decisions that were like based on a monthly or a daily horizon, the idea of running a bad job at the end of the day, collecting data, transforming the data, and then loading it so that business can derive insights work really well. However, as business demands kind of changed and now they're demanding to be able to get insights and being able to make quick decisions in a matter of few minutes, whether it's reactive or in a matter of milliseconds, where people want to just predict the next step of their customers' behavior and being able to appropriately adjust the overall user experience. The idea of using a batch process that works once in a day doesn't really work. And that's where data streaming really comes to the fore. The idea of a data stream is the ability to ingest really small records and a really high throughput of data that is coming in, and being able to process that on the fly and being able to get insights of that data very quickly to be able to make timely decisions. So the goal here is you're moving to a world where you're ingesting a lot of data at a low latency. You're able to deliver quick results for the business. So let's take an example to better understand this phenomenon, right? So I know everybody plays, hopefully everybody plays Fortnite. I do, a big fan of Fortnite. And Epic Games, who operate that game, the business challenge they had was, how do you analyze several millions of events that get generated every minute across wide variety of data sources, including gaming clients, gaming servers, to really understand and adapt to how a player is playing and so on and so forth. So some of the use cases they encountered was, say a player is playing a game, you obviously want to incentivize them for obviously playing the game, and how do you give them rewards and incentives essentially to increase the overall engagement? Or how do you gather this data so that there's a constant feedback loop for the designers, all the way up to minute level analysis to look at gamer satisfaction as they're playing the game, and use the data and insights to drive better gamer engagement. And Epic Games turned over to Kinesis and other AWS analytics services to be able to ingest this high throughput data, use the powerful AWS services that we have, including EMR, EC2, and Kinesis, to process this data in real time and be able to address the use cases that we talked about. Again, here's an example of a customer that is turned to data streaming to be able to accelerate the pace at which they're making decisions. This phenomenon exists across industries, and it could be security monitoring, where you are capturing videos and being able to derive insights out of that, or industrial automation, where there's a significant amount of data that gets produced on a shop floor, and you want to analyze the data in real time to make decisions on the shop floor. Or it could be log analytics, where a lot of data is captured across application servers, across mobile devices, across IoT sensors. How do you gather all of these data and being able to move that to a processing layer and derive insights much faster. Or it could be a very simple use case where you want to move data off to a data lake, something that's based on Amazon S3 or other data lakes. You want to quickly move this data and being able to run, more in-depth processing to generate even more richer insights. Again, like I mentioned before, typically this was a process that would happen at the end of the day. So the time it takes for you to derive these insights, where you're looking at 24 hours over data to derive insights. Now, when you use streaming, as you're getting new data, you're updating the data that exists in the data lake. So the decisions that you're making or the inferences that you're making are based on near real-time data. Data streaming has also found adoption when you're building microservices architecture, where you have hundreds of microservices that have to communicate in real time, and you want to build these lightweighted applications that have very little dependency on each other. Data streaming serves as the central nervous system that binds all of these multiple applications together. Again, the breadth and the use of data streaming services only continues to expand, and these are some of the use cases that we see customers use streaming for. What is data streaming? We talked about why customers want to adopt data streaming and some of the use cases that are around data streaming. Let's talk about how do you implement data streaming? So typically, like I said, the technical requirements of building a streaming platform is really about how do I take a lot of high throughput data and process that very quickly at a really low latency. For that, when you kind of look at the streaming platform, you're looking at 5 distinct layers. The first is the sources or the device, like as an example, devices, applications that are producing a lot of data, and then you're collecting the data across these variety of different sources, and then you're storing the data. And when you store the data, you want to ensure that you have really high durability of that data that's being stored, high availability, so that you're not losing any data. And then once you store the data, the next step is you want to process the data in real time. So you're collecting these smaller records, you're applying, logic and processing, if you will, on the data that has been stored in the storage layer, and then driving real-time insights. And once you collect those insights, you certainly want to store them either in a data lake, which is the most common use case, or another analytical downstream service, as an example, Elasticsearch. So the idea there is, how do you collect a lot of data from a wide variety of sources, store it in a more durable and highly available fashion, and then being able to analyze this data in real time? That's how you want to think about the overall streaming platform. Again, as you can see here, you're dividing this into stages. But again, you want to ask and say, hey, how do I simplify this? This seems to be great value in doing data streaming, but how do I simplify this, right? And the way AWS approaches data streaming is to be able to provide managed service options that makes the overall data streaming pretty easy for customers. So for that sake, over time we have launched 3 specific services that address different needs for data streaming. The first is Kinesis data streams. The idea for Kinesis data streams is to collect and store large volumes of data and make sure it's available for your data processing applications at really low latency. Kinesis Data Firehouse is designed to be able to load a lot of data into a wide variety of data sources. So here you're collecting data, you are then delivering this data to multiple destinations. Amazon Kinesis Data Analytics is designed to be able to analyze data that you're collecting and storing in Kinesis data streams and Firehouse. So here you are able to use either SQL-based code or Java-based code to be able to run analytics on top of the data that is being collected and stored in Kinesis data streams. One of the core requirements of a streaming storage platform is to ensure that it provides high durability and highly consistent storage for your applications. Kinesis data streams does this by replicating all the data that has been written into it into 3 different availability zones. In fact, it offers a 99.9% SLA for durability of data. The second important technical requirement for streaming is the ability to add more consumers. Kinesis data streams supports adding up to 24 consumers to a data stream. The third key requirement is the ability to obviously to process a lot of data very quickly, so that business can actually make timely decisions, things that we talked about previously. The way Kinesis does this is by supporting this concept called shards. A data stream, similar to like a table in a database or analogous to a table in a database, is what you create to start writing data to Kinesis data streams. A data stream is made up of units called shards. A shard acts as a unit of throughput, also as a unit of parallelism. Now, for you to process large volumes of data, one of the foundation things that you have to do is to distribute this data and be able to process these smaller chunks of data so that you can do that at a much lower latency. This is very similar to MapReduce, but applying it to a real-time scenario. So with Kinesis, when you're writing data, you specify a partition key. The partition key decides how the data is distributed across different shards in a Kinesis data streams. Let's take an example to understand this better. Say you're building a multiplayer game, and the goal is you want to observe how players are interacting with different aspects of the game and be able to make some real-time decisions. So in this case, what you could do is, as you're writing different records across different gaming consoles, different gaming servers, you basically use the player ID as a partition key. So when you use the player ID as a partition key, what happens is all the data records relevant to that particular player, as an example, as you can see in the picture here, all records related to player 1, 2, 3, 4, and 5 are written to shard 1. All records related to players 6, 7, 8, and 9 are written to shard 2, and so on and so forth. The benefit of doing this is when you're processing the data, say you are trying to compute a metrics like how long in the last 5 minutes, how many times has this player chosen an additional life, or whatever that metric that you're calculating. All the data for that player is in the same thread essentially that you're processing, which is analogous to that shard. Because it's in the same thread, you're able to do these computations a lot faster, and being able to do this at a very low latency. So the partition key is what decides how data is distributed to shards and how the data is processed by your consuming applications. Kinesis does give you a way to abstract shards from your producing applications and consuming applications, because you're providing a partition key, which is your business ID, like a player ID in this example. You don't have to worry about which shard it is written. At the end of the day, we take the player ID, do an MD5 checksum of it, and then resolve it to one shard that exists in your data stream, and then route the relevance to the appropriate shard. That abstraction is very critical for how your producing applications and consuming applications can adapt in an ongoing fashion. Kinesis also works like as a time-based seek when you're retrieving data. So you can have up to 7-day retention for a Kinesis data stream, and you can use the iterator to go at any given point of time and start processing from then onwards. Think of it as a big pointer that you're using to go back in the stream and start retrieving data from. The iterator enables you to achieve certain guarantees, such as at least once processing, where you can keep track of the last record that was processed. And if there's a failure for your downstream applications, when it comes back, it knows where to pick the processing from. So those are some of the foundational elements of Kinesis data streams. Now let's talk about some of the big benefits of using Amazon Kinesis. Now, we have seen why customers do data streaming. We've talked about how they could use it in some use cases, and then we talked about some fundamentals. Now let's talk about how do you use it? And customers have used Kinesis for the past several years since its launch in 2013, and there are 5 areas that we've heard from customers as to why Kinesis is a choice for them when it comes to data streaming. The first area is about it's easy to get started, right? That's how you start, right? The first thing you would do is you need to get started on any technology. So the amount of learning curve that is needed to get started on Kinesis is significantly lower compared to other data streaming solutions. And let's see why. So you first start by creating a data stream, and all you have to do is give a name, specify the number of shards, That's all you have to do. There are no servers, storage to maintain or manage for you as a customer. Given it's a purely serverless service and it's a managed service, you don't have to worry about managing the underlying infrastructure. Obviously, not being able to manage servers and storage is almost table stakes. Where Kinesis is also even more useful is because each shard provides guaranteed throughput of 1 megabytes per second for writes and 2 megabytes per second for reads. It makes it very easy for you to size and get started irrespective of the scale of the application. So you don't have to, all you need to know is what throughput do you expect on the stream, and you can go size how many shards you want, and then basically get started. You're not really worried about translating those throughput requirements into the type of instances you need, the amount of storage do you need, what are the scaling cliffs, if you will, as your throughput increase. You don't have to worry about that. All you have to know is your throughput requirements. You translate that into number of shards, you specify the quantity, and you can get started. And the creation of a data stream and getting started, even at a really high scale, it happens in a few minutes. So you can go start creating. You can create a data stream with the right necessary throughput in a matter of a few minutes. All right, so I created a data stream. That's great. Now, but how do I produce the data? Well, for that is also critically important, right? That step is also something that Kinesis data streams makes it very easy for customers. We provide a wide variety of options, including toolkits such as the Kinesis producer library, a Kinesis agent, and obviously the AWS SDK for you to easily pull, as an example, log files from servers, or basically build a highly available ingestion platform. The goal is to make it easy for customers to move data into Kinesis. We also provide service integrations, including with CloudWatch Logs, IoT Core, and few others, so that it's just plug and play for you. Set up certain configurations, as an example, on CloudWatch Logs, and you can get started by moving the data or streaming the data into Kinesis. We also have third-party offerings, including Log4j, FluentD, that customers use at scale to be able to capture data and send it to Kinesis. So you obviously, now you created a stream, you're able to produce data into this stream. Now you have to process that data, right? When we talked about this, we offer a managed service called Amazon Kinesis Data Firehouse that makes it a simple experience for you to move data to the destination of your choice. It could be to Amazon S3, it could be Amazon Redshift or Amazon Elasticsearch, or it could be to generic HTTP endpoints that you want. We launched this feature of being able to deliver data to HTTP endpoints a week back, and something that I would certainly want to try. Again, the idea here is you have all the data in the Kinesis data streams, but you want to deliver this data as part of your workflow to different destinations. You can quickly integrate data firehouse, connect a data firehouse to a Kinesis data stream, and deliver the data to the choice of destination that you want. Or certainly delivering data is one use case, but say you want to do some processing as you're collecting this data. It could be simple transformations. It could be some complicated math function. There is some processing logic. For really simple processing logic, and if you really don't want to worry about managing infrastructure, you just want to focus on writing the logic, maintaining the logic, AWS Lambda provides the most easiest option. You can choose your programming language of your choice that AWS Lambda supports, and all the integration that is necessary to retrieve data from Kinesis, provide guarantees like at least one semantics, and all of that heavy lifting is done by the integration that AWS Lambda has with Kinesis. So when we say that, hey, Kinesis data streams is integrated with AWS Lambda, what we're meaning is we're trying to make it so simple for customers to just worry about writing their logic and leave the job of being able to retrieve the data and be able to guarantee semantics to us, to AWS, and thereby you're just focused on writing the processing logic. Say you want to use SQL, because a lot of data analysts, if you will, around the world are very comfortable with SQL, and say you want to apply the same SQL semantics on streaming data. Now, for those type of use cases, we offer a managed service called Kinesis Data Analytics. Kinesis Data Analytics is a fully managed, serverless service that allows you to connect to a Kinesis data stream and discover the schema of the data that you have, and then be able to write SQL queries on top of this data. So you're able to run queries such as window queries, where you say, hey, give me the metric over the last 5 minutes, or the last, or give me a stat of a metric over the last X minutes. So you can do a bunch of these processing of data on top of streaming data very quickly using Kinesis Data Analytics. However, if you have complex requirements for doing more stateful processing, say you want to join a bunch of data streams, be able to reason from how data exists between different data streams, or you need a more stronger guarantees such as exactly once processing. For some of those use cases, we built Kinesis Data Analytics for Java, which uses Apache Flink, an open source framework for stateful processing. And again, even in this case, you're not worried about managing server and storage. You're focused on using Apache Flink semantics to write the processing code that is needed, connect to the data stream that you have, and quickly build applications. Things that have taken you months can now be done in a few hours. So one of the common things that you can see with all these integrations is the fact that it's very easy for you to get started. All you need to know is the amount of throughput that you want. You have existing integrations that you can use in about a single click. You can start producing data into Kinesis, and then you have managed services that allow you to take your code and run it on these managed services to be able to process the data very quickly. And regardless of the sophistication of that of the processing code, we have different options, if you will, that you can choose from. All right, so when we talk about integrations, things that are important for you to build enterprise-grade applications so that you have the right set of controls, the right set of security requirements. And we got integrations with things like identity and access management, key management service, Amazon VPC, and private link for you to build these stream processing applications, streaming platform essentially, with the right set of security requirements that your enterprise might have. We also have integrations with a wide variety of services like API Gateway, Event Bridge, and Pinpoint. Depending on the use case, again, producing data using these integrations is pretty much setting up a configuration in each of these services. We're also through Kinesis Data Firehouse and with integrations like database migration service, delivering data to different databases for things like change data capture use cases is very simple with Kinesis data streams. It's just not about AWS services integrations. We also have third-party connectors, including and not limited to things like FluentD, MongoDB, Datadog, and MemSQL. So the idea there is the ability to deliver data as well as be able to produce data from wide variety of different sources and destinations. All right, so we talked about the first superpower, which is that, hey, it's easy to get started. But starting is just one half of it, right? You size your workload, you know what is the integration that you need based on the use case. Now you're running it, right? But there are aspects of operating that become very critical. Certain things like high durability, high availability, we've talked about it, they come default with the service. But again, you still have to operate the service as the workload changes. And every data streaming workload evolves over time. So you start with a set of assumptions around throughput, and those always change. As an example, as a gaming company, I launch a game, there's certain expectation on how well the game does, and say there is a hockey stick growth for that game, and demand suddenly explodes. You need to ensure that the data stream can adapt to these incredible increase in demands that you can see very quickly. The way Kinesis does is really leveraging the power of shards and being able to use that to quickly scale capacity as needed. We've talked a little bit about this. Shards act as a unit of parallelism. They also act as a unit of throughput. Each shard provides, like we discussed, 1 megabytes per second for writes and 2 megabytes per second for reads. So say my requirements are like, I just have 1 megabytes per second across a couple of producers that I have, and I have a couple of consumers in my stream. Now, say I know that and all I need is one shot to be able to address that demand. But say if my growth is going to grow to 10 megabytes per second, and as my demand is growing to 10 megabytes per second, what I can do is I can add more shards or more capacity to my stream. And doing this can be done in a way that doesn't really disrupt your producing and consuming applications. So if you remember, you use a partition key to write data to a Kinesis stream. Because you're using a partition key, which is something that you control, and you're not directly interacting with a shard to write this data, you don't have to worry about how many shards are being added. And every time you change the shard count, you don't have to go change the producers and the consuming applications, and thereby ensuring that you're not disrupting the entire workflow. Now, how is this important? The reason this is important is it gives you the flexibility that is needed, because you can grow capacity, reduce capacity without worrying about all the impact it would have on producing and consuming applications. It just makes it much more easier, you as an operator, for you to run the data streaming platform. The second most important requirement is to be ability to identify and remediate issues, right? So now you're operating a distributed service that has a bunch of producers and a bunch of consumers. Certainly, it's important for you to identify issue and resolve it. So in integration with CloudWatch that Kinesis Data Streams has makes it extremely easy for you to identify issues. Now you can do that at the stream level, and optionally you can do it at the shard level. So you can look at both on the right side. Am I getting any, how is my incoming data growing over time? Is there any consumer that is falling behind, as you can see there with the iterator age? It really allows you and ensures that the producing applications, the consuming applications are interacting to the data stream appropriately. And if there's an issue, you can remediate very quickly. As an example, if you notice that you don't have enough shards in your stream, and you see a consistent increase or a consistent write throughput exceeded exceptions, what you could quickly do is you can add more shards to that stream and thereby address the increase in capacity that you've observed. We also offer the libraries and other utilities to automate this, where you can alarm on CloudWatch metrics and then appropriately increase the number of shards to handle the anomaly that you observed. So we've talked about how easy it is to get started. We also talked about how easy it is to operate, and the crux of this is really about the notion that you're not really bounded by some of the sizing decisions that you would make. Kinesis data streams can easily adapt as your traffic patterns change, and without causing much disruption. It also provides the ability for you to identify and remediate issues. Again, key things that are important for operators. Talking about scaling, one of the things that you would want to think about when you're looking at a technology is how scalable is this technology, right? And Kinesis data streams doesn't have any limits on how many number of shards you can have on a stream, right? So it can scale to a large amount of throughput that you could have. So as an example, you could say you're launching a product essentially, and you expect significant increase in throughput. And it could be as high as, let's say, 4 gigabytes per second. And Kinesis, you could basically size the Kinesis stream with the appropriate number of shards to be able to add, to address the peak throughput that you would see in a day, like 4 gigabytes per second. That's a lot of data, right? And what you can also do is say that now you don't expect demand, that demand lasted during, let's say, Black Friday, and you had a lot of sales, and now now that it's no longer the holiday season, you don't operate the peak wall data traffic that you've seen. Again, going back to the fact that Kinesis can easily adapt to these changing data patterns, you can go and decrease the number of shards in that Kinesis data streams using a single API call, and then decrease the overall capacity. And obviously that allows you to balance both availability and cost. Again, the key idea here is Kinesis data streams provides you the ability to grow your capacity as it's needed, both up and down. So we talked about high throughput, and again, the other important of scalability is the ability to add more consumers. So as a data stream matures essentially, or streaming platform evolves in your organization, you certainly want to add more consumers that can benefit from from the data that is being captured in a stream. For that reason, Kinesis data stream supports enhanced fan-out consumers. You can add up to 20 enhanced fan-out consumers to a Kinesis data stream. So as your data stream platform grows, you can add more consumers. The second key benefit is it provides less than 100 milliseconds end-to-end latency. Now, the reason this is critical is you could have a bunch of applications that are very latency sensitive, and you want to really reduce the time it takes from record is produced, the time it's actually available for you to process. Now, with enhanced fan-out, you can ensure that overall propagation delay is less than 100 milliseconds. The third key benefit that enhanced fan-out provides is each of this consumer that you're adding gets its own dedicated bandwidth. So it gets its own lane essentially, right? Now, why is this important? Say you have a data stream that has two different applications. One is a mission critical application that powers how the website functions and it's very critical. And then you have another consumer that's basically collecting metrics of what users are doing for retrospective analysis and so on and so forth. Now, let's say the second application consumer spikes, and when that happens, you don't want it to compete for the bandwidth that is being shared with the first application. So you don't want to share any bandwidth between these two consumers. Now, with enhanced fan-out, what you can do is you can create an enhanced fan-out consumer for that mission critical application, ensuring that that application gets dedicated bandwidth and doesn't have any performance problems when things change with other applications running on the Kinesis data stream. That's the third key benefit with enhanced fan-out. So we've talked about how easy it is to use Kinesis. We've talked about how easy it is to get started. We've talked about highly scalable aspects of Kinesis and how you can do that at a really low latency. Now let's talk about the last key benefit, which is the cost effectiveness side of Kinesis. There are three aspects of Kinesis that makes it very cost effective. The first is there is no upfront costs and there are no minimum fees. And there's a pay-as-you-go model. You pay by the short hour, and you pay by the number of consumers you have on the application for enhanced fan-out, and you pay for additional features as you enable them, whether it's enhanced metrics or extended retention that provides you greater than 24 hours of retention. Again, the ability to add the feature that you want to a data stream that you need and be able to toggle back and forth depending on use case makes Kinesis data streams very cost effective. The second aspect is, it has a very low operational overhead, right? So you don't have to manage compute and storage infrastructure. So certainly, as an the aspect of making sure you have highly available and highly durable infrastructure is on AWS. So again, that lowers the overall cost of ownership on operating streaming platform. The third three key aspect is the granular scaling that Kinesis offers, right? So when you have scale capacity, you can scale that in a very granular fashion. You can also scale up and scale down and do it in a fashion that is not disruptive to your producing and consuming applications. That becomes very critical when you're operating a massively scalable infrastructure where you don't have to worry about scaling cliffs so that you're not over provisioning your infrastructure. You know that growing and resizing that capacity is not going to cause a whole lot of disruption to your producing and consuming applications. Doing that means that you can optimize the capacity depending on your data traffic and thereby have overall lower costs for operating a data stream. Again, the goal here is to provide the right set of tools for customers to be able to effectively manage both availability and cost depending on the type of use case that you have. So we've talked about data streaming. We've covered how Kinesis, how it works. We also talked about some of the advantages that customers see with Kinesis and Kinesis data streams. Now let's talk about how can you get started. What are some of the use cases that I can quickly get started with data streaming and Kinesis? The first one is really about log ingestion to really process large volumes of data in real time. So you could use Kinesis as a way to collect logs from any different application that you're running in any different compute infrastructure. So it could be an Amazon EC2, could be ECS, Lambda. So you've got a lot of metrics and logs that are being, a lot of data that's being collected in here. Say you want to pull all of the data, and then you can collect that in Kinesis data streams, and then use Firehouse to deliver the data to Elasticsearch or to Amazon S3. Run Athena queries on top of that for you to generate insights, or use Elasticsearch for you to do the analysis that you need across all the logs that you're collecting in your enterprise. So you could actually build a highly scalable, observability platform very quickly using Kinesis and all its integrations with existing AWS services. You don't have to just stop there. Say you now deliver the data to S3, you're doing, say, a near real-time analytics. So say your latency is maybe an hour because you could wait. And now, however, businesses come back and said, hey, we want to generate even faster insights. Now, in those cases, what you could do is you can connect a Kinesis data analytics data analytics to Kinesis data streams and do real-time analytics and be able to generate insights that can then be moved to Amazon CloudWatch for you to observe those metrics. Again, you could start by doing a near real-time like application, and then extend that with Kinesis data analytics to do more real-time analytics. A very, very simple first step that most customers take. The second use case is what is generally referred to as streaming ETL. The goal here is you have a bunch of data sources where you're collecting data from, and you want to move that to a data lake like Amazon S3 for you to run batch analytics or analytics that are based on Amazon S3. Now, for you to do that today, you basically have to collect data across several hours, load that, and then do the processing. Instead, using Kinesis, you could actually collect data in real time, all these small records that you have, batch them, and then basically use Kinesis data analytics to drive some near real-time insights, as well as do things like simple transformation of the data to very complicated transformations. So say you're collecting data from different sources, you want to transform the data in a format that you want, and you want to join across multiple different sources. You can do all of that using Kinesis data analytics and then load that data into Amazon S3 in a structure that is very efficient for your batch processing layer. Or the goal of or you can run insights using Athena and what have you very quickly. This is again a use case where you are reducing the time it takes for you to generate insights, and by using managed services across the board, for you to get started is significantly easier. The third use case that typically customers use data streaming for to get started is really around event streaming and IoT. So imagine you have a use case where you have a lot of sensors that are collecting data and you want to analyze that in real time. Now, in that case, you could use AWS IoT's integration with Kinesis, or build your own ingestion data capture layer, capture the data in Kinesis data streams, use Data Firehouse to move the data to S3, or use something like Lambda to do quick processing and collect those insights and store it in DynamoDB so that's available for your users to access them. So you're going from collecting sensor data to be able to move it into a data lake for in-depth processing, or do some light transformation so that's available for your applications. One of the things that you would see with all these three use cases is Kinesis makes it very easy, and Kinesis, along with all the other AWS services that it integrates with, makes it very easy for you to go from an idea to a design, to a pilot, to a production-ready app in a matter of a few days. And as you scale the capacity of that application that you build, you can do that without any significant overhead. All right, so I think I just want to kind of recap before I want to take questions. Like we've discussed, data streaming is a very powerful construct that has applications across a broad set of industries and use cases, with a core goal of how do we reduce the time it takes for business to make impactful decisions. And even given the power of this technology, what you really need is something to get started very quickly, as well as make it very easy for you to operate, which is something that Amazon Kinesis and all of its integrations deliver for customers. Obviously, we've talked about some getting started use cases, but we also have solution guides that are available online, as well as we provide opportunities such as data labs for you to come talk to us about specific use cases that you have where you see application for data streaming, and our experts will sit down with you to architect that, and then obviously run that, build a pilot for you very quickly, and show you how to operate that for your production traffic. And I just want to now take questions.